Hi all, welcome back to Coding World. Today in this tutorial we are going to learn about load balancing. Load balancing, some people call it as a load balancing, some call as a proxying, some calls as a routing. It is a important concept in nowadays because every company is shifting their architecture from monolithic architecture to microservice architecture. In microservice architecture, we split our application into a functionality, and for each functionality we will be having a separate service. That service will be deployed on different node or same node, or it will be placed on any cloud also. So in that scenario, to maintain all the addresses of your services will be difficult for a client. And to solve that issue, we have come up with the API gateway. And to API gateway also, before that, one more layer is that, which is a load balancer. What load balancer will do actually, and what type of load balancer are available, and how to implement that load balancer in a Java. I will go through this session and will tell you how we will implement that. In this image, we have clear picture of the load balancing above overview. Like you have a client server and you have multiple backend server, and in that between you have a load balancer. We are in this tutorial. I am using a Eruka and Ribbon for the implementing load balancer. So here I have mentioned that naming Eureka naming server. So what actually happens when client request to server, it hits our load balancer. Load balancer will do the service discovery, and it will find out where should this client call route and where that server is located. All that information is saved at a load balancer, and according to that it will transfer your call to the respective server, and the result will be returned in the client after the processing. There are many techniques to route your client call to the server and return the response from the server to client. Here there are two types of mechanism. Like you have to, when first client send to the load balancer will check where is the requested server is located, and it will replace its source with its own IP and destination with the server IP. When server process that request, it will return. It will check where I should redirect this post call or this request. So it will check that source destination from where it has come. So in that, load balancer has already replaced source URL with its own URL. So server will give that response to the app, to the load balancer. In load balancing, it will check in a hashing mechanism will be there, and it will return that response to the our client server. So this is one process. Second process is that, like, client will hit to the load balancer. In load balancer, it will replace its destination from load balance to its server, and server will return that response directly to the client, because load balancer has not changed source destination with its own IP or URL. So this is a second mechanism. So before going to this types of load balancing and all, we will learn about what is the benefits of load balancing. So load balancer features are like, if single server goes down, load balancer removes the server from server group and redirects traffic to the remaining online services. From this, we will achieve our 100% availability. So client will not get the service is not available and all these types of error, and your users will get satisfied because your service is available 24/7. Second benefit is like when a new server is added to the server group, load balancer automatically start to send request to that, because whenever you up your server, it will register to your load balancer, and the load balancer will get to know that, yes, I have added one more service server, and your request will transfer to the that server with our load balancing algorithm. Third one is a distributed client request or network load efficiently across multiple servers. So load balancer have some different types of uh, load balancing algorithm, like a randomly he can send, or round robin technique he can use for send the request to respective client, respective server. Fourth one is ensure high availability and reliability by sending request only to the servers that are online, which I have already explained. Provides the flexibility to add and subtract server as a demand dictates. So there are some systems like which has a high uh, traffic at some specific time and low traffic at the some specific times. Like banking systems are like high traffic at a in a working days, and there will be low traffic at a in a evening or in a night time. So in that time we can add server and we can reduce server on the basis of the time zone and traffic load. Fourth one is like can be added at multiple layers in the application stack. Application server, databases, and cache layer. We can add the application. So when you are using load balancer, you can add the multiple caches at the load balancer to speed up the process and speed up the request response cycle. Last one is can dynamically add or remove servers from the group with without interrupting existence connection. Yeah. So next step is like a load balancing happen at a two level. Like for in OSI level, we can do the load balancing at level 4 and level 7. In level 4, load balancing happens on the basis of your IP and the port, and at level 7, which is the application layer, load balancing happen on the basis of the request header and the attributes which are coming into request header. We will do the data messaging, and on the basis of that we will redirect our request to the respective server. Here you can clearly see that http in http we can find out, we can check the headers of that request, and on the basis of we can redirect our request to respective backend server. So these are the layer load balancing. As of now, you have seen that we have putting our load balancing in the between client and server, and all the request and response come go through the load balancer. So there are different kind of topology which we use for load balancing, which I am mentioning below. Like there are mainly four type of load balancing topology. One is a middle proxy. In middle proxy, what happens, which we have seen early, in client and backend, we are putting our load balancer. In load balancer, all our request and response go through the load balancer. Main this load balancer can be a hardware which Cisco and other competitor company Univar is providing this. So its cost is high, and sometimes when this gets failure, your all service will be in a dead state. Like all service are going through the load balancer. So once load balancer is down, so all service will get shut down. Second one is a edge proxy. Edge proxy it's a variant of middle proxy. In this, we are providing one more internet layer between our client and load balancer. This internet layer can be if your API gateway instead of coming directly to load balancer, it will go to the API gateway, and from API gateway to go to the load balancer, and from load balancer it will migrate to destination backend server. Third one is embedded client library. So as you seen in this last two topology, we are not able to we are not able to scale this load balancer. If you want to scale this cost will be getting higher because it is hardware, and so hardware has a high price. So where it's not suitable to scale this load balancer. To solve this issue, they come up with the embedded client library. In that client library, your load balancing load balancing logic and algorithm will be encapsulated in one library, and that library will attach to the service. So whenever uh, we scale our service, that load balancer will automatically scale. So this is a embedded client library. Now fourth one is a sidecar proxy. What happens in sidecar proxy? It's variant of a embedded client library. In this we have split our service and sidecar proxy. If you see in third, we have embedded client library. It shows that a client library is a dependency because it is little difficult when we are implementing our services in different language. So you need to migrate your service, you need to write your library in that service also. We so client service client library service is a dependency in embedded client library. To to solve this problem, we come up with a sidecar proxy. In this sidecar proxy is a depend. It's not embedded with a service, so you can implement any language, and you have to send your request to the clients to the side proxy, and side proxy navigate your request to the backend server. So these are the mainly four types of load balancer topology, which are mainly used in current scenarios. This is a theoretical part. I will cover this with our Java implementation. So let's jump to the implementation of the load balancer using a Spring application with the Eureka naming server and a ribbon dependency. To make this tutorial speedy, I have already created our client service, backend service, and our load balancer. I will tell you step by step what exactly we have did in client server and the load balancer. So let's start with our client service. In client service, if you see that we have API proxy interface. In API proxy interface, we have one method uh, which is a retrieve technology info, which we can consider as a gate API. So then we have a client controller. In this client controller, we are calling API proxy to get our technology information. So from UI, we will hit our technology slash whatever technology consider as a Java, Oracle, and C, C++. We will hit this URL from client side. It will navigate to the API proxy. API proxy call our load balancer, and load balancer will find out the exact server, and from that server it will return our response. This is a flow of this load balancer. In this we have a main class. In main class we have to add two annotation like enable fusion clients and enable discovery client, which will be used to find out our load balancer and register our client to the load balancer. Fourth class is like response model. This will we will use to show our response from the backend. In application properties, we have mentioned that our service context path, then our application name, our port where our application is running, and this is the main thing where we are hitting. This is the location where our port, our API gateway, sorry, our load balancer is running. Next service is a, let me tell you about microservice server. In this we have main class. In this main class we have added enable discovery client annotation, which will use to discover where exactly our load balancer is running. And whenever we up our microservice, we need to register that service to the load balancer. So henceforth, load balancer will get to know that how many live server I have and how many are down. So with that information, he can redirect a client service to the active or online server. Response model, this will use to response client where we are setting title, platform, server port. So we will get to know that from which server it is coming. Server controller, this is the URL gate mapping we are hitting from our client. So in that we are checking that if technology is Java, we are setting technology stack and the information platform. These are the basic things. And then we are setting our port from our property and we are returning response model. In application.properties file, in this we have mentioning our application name, the port where it is running, and the Eruka naming server where our load balancer is running. Coming to our load balancing server, we have only one extra annotation which is a enable Eureka server, which will have other annotation which will register, help to getting register servers and routing our client requested to register servers. So let's run this service and check our routing is happening properly or not with the load balancing. Now we will run our load balancer. So once load balancer will get up, all your client and your server get registered with our load balancer. I will run load balancer as a Spring Boot application. You can see in log. I will zoom out. So it's running. Yeah, it's printing our like logs like it is running on 878 8761 and it successfully started. Now our load balancer has started on 8761 port. You can open this in our Chrome browser and we can check the service is running or not. Localhost colon 8761. Yes, load balancer is running and it is giving us a beautiful dashboard where you can able to see like application which are registered with the load balancer. Currently it is showing that no instance available. Instance currently registered with Eureka. So currently we don't have any register. There are different information which we can use. like current memory usage, how many it has used, server uptime, and register replicas. This information we can use. Okay. So this server, after a specific time, it will hit our services and it will populate the health of our application on this dashboard. Now let me run our client. When we'll run our client, it should register with a load balancer and that entry will come here. In this tutorial, we are making one scenario like we will be having one client and a two server. So same server I will run with a defined port and one with a overridden port. So let me start first client, then we will see server. Client is running. Yes, it successfully started and it has registered with the Eureka server also. In log also you can able to see that. Yes. So our server is started on so our client is started on 500 and it's registered our load balancer, getting all instance. Yeah. In Eruka server also we are getting those entries like microservice client, which is running on this 500 port. It's registered with the client. If you hit our dashboard, you will able to see that application client, microservice client with the availability zone 1 is registered. Now we will register our server with the two instances. Let me go here. If you see in application property, default port is a 4000. I will run this application with a 4000 instance and 4001 instance. Yeah, it started on 4001 because for this server I already configured as a 400 4001. Yes, server has been started and got registered with our Eureka server also. Let me go and change configuration, run configuration of the server. In arguments, I have already configured 4001. I will remove that so it will start on default configured port. If I run, it should start on 400. So in that way, we have one client instance and two server instance. And in that between, we have our load balancer. When client hit, it should it should redirect to 400 or 4001 according to the load balancing algorithm. Yes, it started on 400. So if you check our dashboard, we have microservice server 2 instance available and microservice client 1 instance available. Now we will hit our client, it will and we'll check how that balanced with a 2 server. Okay, let me hit our client URL. Client URL is a localhost 500 microservice client technology info slash our technology. Yes, this is routing to our 4001. Now magic will happen. If you refresh, it will go to the 400. That means our Eruka naming server is doing a proper load balancing. Once like it's kind of round robin, like once it's served, it will be placed at last position, and the last second one which are in queue will be picked up. So this is a load balancing load balancer with a Spring Boot application with a Eureka naming server and the ribbon dependency. So guys, you have seen that how load balancer has implemented in a Spring Boot Java application and with a one client and two instance of a server. So if you like this type of video, small video where you are getting your concept clear and the new technology which are in market, so ping me in our chat box. I will create the video on that and will publish in my channel. If you like this video, please subscribe and do the like. It will motivate us to do more video. Thank you.